The curse of the curve. What is curvature? If we look at a marble and a basketball, we see that both have a round shape. But the radii are different. Curvature is defined as 1 divided by the radius of a circle or sphere or curve. The bigger the radius, the smaller the curvature. A straight line has 0 curvature, a point has infinite curvature. Because the marble has a smaller radius, its curvature is bigger than that of the basketball. But how about Earth? If Earth is a sphere, it too has a curvature, but with a very big radius of over 6,000 kilometers. It is much bigger than the radius of a basketball, and so Earth's curvature is much smaller than that of a basketball, which in turn makes it more difficult to observe. If Earth was flat, the surface would follow a straight line of 0 curvature. So the question is, do we see any evidence of curvature? Yes, actually. At least in a forwards direction. Each sunset shows that the sun does not disappear in a distance, but sink behind the horizon. It disappears behind the curvature, and due to refraction effects later than it should. Or when you cross a large sea and approach land, you see it rise from behind the horizon. Or if you look at the night sky, the further south you go, the more new constellations show up. You can even observe that the northern constellations rotate anti-clockwise, while the southern constellations rotate clockwise. This can only be explained on a rotating sphere. Although there have been desperate attempts lately to squeeze these observed facts into flat Earth models. But either you need giant mirrors, which could only work in one place when you do not look too picky, or each time you cross the equator you turn around the whole planet with a jerk. Funny. Although Pythagoras already taught his students that the Earth was a sphere, it was Eratosthenes who first seems to have calculated its size. He thought, Earth is a sphere, and the sun is so far away that the sunbeams are almost parallel. He found out that when the sun is right above Aswan, it casts a shadow behind a stick in Alexandria. The angle of that shadow was 7.3 degrees. He also knew the distance between Aswan and Alexandria. If we divide the full circle's 360 degrees by 7.3 degrees, we have about a 50th of a circle. If we now multiply the distance between Aswan and Alexandria with 50, we will get the circumference of our Earth. He came pretty close to Wikipedia. But what if his premises were wrong? If the Earth was flat and the Sun was so close that its beams are not parallel, couldn't we measure the same angle? Sure, but only if the Sun is very close, and we can check it by using a third point further north. The angles of the shadows would have to be trigonometrically consistent, and it would make a huge difference if the Earth was a plane or a globe. But why don't we see a sideways curvature? And that leads us to the next contribution from Eric D. from T.
Anyone can prove the sea horizon perfectly straight and the earth perfectly flat using nothing more than a level, tripods, and a wooden plank. At any altitude above sea level, simply fix a 6 to 12 foot long smooth leveled board edgewise upon tripods and observe the skyline from eye level behind it. The distant horizon will always appear perfectly level with the upper edge of the board. Furthermore, if you move in a half circle from one end of the board to the other, whilst observing the skyline over the upper edge, you will be able to trace a clear, flat 10 to 20 miles depending on your altitude. This would be impossible if the Earth were a globe 25,000 miles in circumference. The horizon would align over the center of the board, but then gradually, noticeably decline towards the extremities. Just 10 miles on each side would necessitate an easily visible curvature of 66.6 feet from each end to the center.
Okay, Eric, let's follow your line of argumentation for a moment. Let's turn around in a circle. If you really think the horizon has to fall towards the sides, it has to fall the whole time. This is how that would look like. Because the horizon would bend to both sides, you would inevitably end up with something like this in your bag. Does that look like a sphere? To find out why there is no visible sideways curvature, let us look at a ball and a tower. Standing on top of the tower, you may have a sight of, let's say, 20 miles to the east and to the south, and 20 miles to the west. In short, you have a sight of 20 miles into all directions. When we connect the furthest points, we get a circle. And this circle marks a round plane, on land as well as on sea. Even from a plane, and even if they fly above a giant cube, you will always get a circular, flat plane. There is simply no way you could see a sideways curvature. When you live on a small asteroid like the Little Prince, it is easy to see its curvature. But such an asteroid does not have enough mass to hold an atmosphere. If you want to breathe, you need something bigger. And that's where you lose track of curvature. And this is the perfect transition to our next question from Seventh Day Truth Seeker. First of all, I don't think it's such a good idea to seek the truth on the seventh day, because usually the libraries are closed then, and only the churches are open. But well, let's hear what he says.
I'm reading from The Greatest Lie on Earth, proof that our world is not a moving globe. However, when large, expansive areas of land are considered, it can be determined that land is not convex, as would be expected on a spherical Earth. Land is generally flat. Scientific research proves that fact. For example, Mark Fonstad, Ph.D., William Pugach, and Brandon Vogt, Ph.D., used data from the United States Geological Survey to determine that, on scale, the state of Kansas is literally flatter than a pancake.
Well, it looks like when the scientists have fun, the statistics get serious. First of all, the talk is about a perfectly valid scientific investigation done by geographers from Texas and Arizona State University. You can find it here. What did they do? First, they scanned a pancake. Not a cheap supermarket one, but, as they state in their paper, a well-cooked pancake from a local restaurant, the International House of Pancakes. They cut away a 2 cm wide sample strip and probably ate up the rest. Then they took a photo of the pancake strip and measured its surface topography by digital image processing. A second scan was done with a confocal laser microscope. So they got the surface diagram for the pancake. It looks like this. But how about Kansas? How did they measure this? In principle, they did exactly the same as with the pancake. They used photos and distance measurements from US Geo Survey airplanes. These planes fly at a certain height and take stereo photos and radar surface measurements. Here is what they found. At first glance we see that Kansas has a slope. It is higher in the west than in the east. But apart from that, when Earth has a curvature, shouldn't it more look like this? No, because a plane that keeps a certain flight height above sea level follows the curvature as well. You could compare it with a bicycle wheel. The tire, held by spokes, always keeps the same distance to the hub, and the airplane is held by gravity. So if you throw a pancake onto a sphere and fly over it, yes, it does look a little bit like Kansas. And this is a perfect opportunity to correct another strange view of Eric D. from T.
15. If the Earth were truly a sphere 25,000 miles in circumference, airplane pilots would have to constantly correct their altitudes downwards so as to not fly straight off into outer space. A pilot wishing to simply maintain their altitude at a typical cruising speed of 500 miles per hour would have to constantly dip their nose downwards and descend 2,777 feet, over half a mile, every minute. Otherwise, without compensation, in 1 hour's time, the pilot would find themselves 31.5 miles higher than expected.
First of all, you may calm down. You won't fly into space with a normal airplane. Gravity will prevent that. But let's have a look at what makes an airplane fly, shall we? When an airplane moves forward, air streams around its wings. The wings have such a shape that the air above the wing has a longer way than the air below the wing. This makes the upper stream faster and lowers the air pressure above the wing. Because the air pressure below the wing is higher, the airplane feels an upward force. If this upward force is stronger than gravity, the plane gets lifted up. It is a constant fight between the uplift and gravity. And because gravity always is directed to the center of Earth, the plane itself stays at the same distance as long as the speed and air pressure are the same. The pilot does not have to adjust the nose downward because there is no up and down. But people who believe the Earth is flat constantly mix up curvature with elevation, as the following quotation shows.
11. A surveyor and engineer of 30 years published in the Birmingham Weekly Mercury stated, "I am thoroughly acquainted with the theory and practice of civil engineering. However bigoted some of our professors may be in the theory of surveying, according to the prescribed rules, yet it is well known amongst us that such theoretical measurements are incapable of any practical illustration. All our locomotives are designed to run on what may be regarded as true levels or flats. There are, of course, partial inclines or gradients here and there, but they are always accurately defined and must be carefully traversed. but anything approaching to 8 inches in the mile, increasing as the square of the distance, could not be worked by any engine that was ever yet constructed. Taking one station with another, all over England and Scotland, it may be stated that all the platforms are on the same relative level. The distance between eastern and western coasts of England may be set down as 300 miles. If the prescribed curvature was indeed as represented, the central stations at Rugby or Warwick ought to be close upon 3 miles higher than a cord drawn from the two extremities. If such was the case, there is not a driver or stoker within the kingdom that would be found to take charge of the train. We can only laugh at those of your readers who seriously give us credit for such venturesome exploits as running trains round spherical curves. Horizontal curves on levels are dangerous enough. Vertical curves would be 1,000 times worse, and with our rolling stock constructed as at present, physically impossible.
Okay, let's repeat that. We have a railway station here and a railway station there. We have the rails between them and the mountain top of curvature. Welcome to the Southern England Highland Railway. Now, before you start pushing trains over the curvature, you should consider this. What exactly defines up and down? Downwards usually is the direction into which the apple falls. But why does the apple fall down at all? Because of gravity. It pulls the apple towards the center of the earth, no matter from which direction. So the only thing that is important for the definition of up and down is the distance to the center of gravity. In our case, the center of Earth. And as long as two railway stations and the rails in between have the same distance to the center, they also have the same elevation. No need to push a train over the curvature. But because it is difficult to measure distances from the center of Earth, we usually measure heights from the mean sea level, because water usually levels itself. Level? Didn't Eric say...
3. The natural physics of water is to find and maintain its level. If Earth were a giant sphere tilted, wobbling, and hurtling through infinite space, then truly flat, consistently level surfaces would not exist here.
Seems Eric can only imagine a water level on a flat Earth.
But since Earth is in fact an extended flat plane, this fundamental physical property of fluids finding and remaining level is consistent with experience and common sense.
Okay, let's try it again. As I told you before, curvature does not mean elevation. The force of gravity depends on the distance to the center. Same distance, same gravity, same pull. That also goes for water. Each drop on the water surface feels the same pull when the distance to Earth's center is the same. Water levels around a sphere in the shape of a sphere. The math of curvature. Although flat Earth usually is a strictly no-math zone, there is one formula that is almost beaten into the brains of the community. The 8 inches per mile squared formula. They say, if there was a curvature, we could not see anything behind it. But because we often can see much further than curvature would allow, there cannot be any curvature. The 8-inch formula is a rule of thumb and basically calculates how much height is hidden below the sideline that touches the horizon. Then they compare it with heights of buildings, mostly lighthouses, and show that we shouldn't be able to see them behind the curve. There are some problems with this formula. A. Geometrical ones. Often they forget to include the viewer's height and the part of the distance before the horizon in their calculation. They measure their distances along the curved surface of Earth, but only calculate a straight line distance. And they simplify the calculation by using a truncated formula. But as I said, it is only a rule of thumb that is pretty close to the geometrical reality on short distances. The problem is more a physical one. In all the flat Earth models, there seems to be no refraction. All sidelines are straight. But if refraction bends light downward, you can actually see much further on a curved planet, sometimes even hundreds of miles. If you want to find out more about refraction, watch my video, The Last Light Bender. And this will be the end of our curve discussion.